Lab 5. Create your own adventure. In this lab, I decided to find the force of a push using Newton's second law when I knew both F net and the force of friction. However, the result of this lab is inconclusive due to some mistakes made, which I will discuss later. In this demonstration, I slid a rubber case on a piece of cardboard to model the effect of friction. I used Newton's second law and Newton's second law in the form of the momentum principle as F net equals dp over dt and F net equals the force of friction plus the force of the push when we know that friction equals mu times the normal force, which in our case, the normal force is just mg. The initial conditions were the mass of the rubber case, the coefficient of friction, which I found online, and, of course, the given constant g. In this computational model, I chose the correct axes and set the calibration stick and tracker, and I took the data of time versus position in the x component from tracker and saved that in a 2-column CSV file. I then used the code from Lab 3 to set up the indexing and taking data from the CSV file. This then calculated the change in position over change in time to equal velocity, and if you multiply that by the mass, it equals momentum, and then F net equals the change in momentum over change in time. F net also equals the force of friction plus the force of the push, and we already know what F net, the force of friction is, and so therefore we'll be able to calculate the force of the push is equal to the net force on the object minus the force of friction. However, there were some problems after working on this code for 4 hours, errors that I could not figure out. I don't have any results, so therefore I don't have any results to analyze or compare my findings to. However, in theory, should the model have worked the way it was supposed to, it would have printed and found the values for F net, the force of friction, and therefore would have been able to calculate the force of the push on the case, which hopefully would have been a reasonable value for the force my hand could have pushed. Some sources of error. First of all, using old code is tricky because finding the phys-util file that comes with it sometimes doesn't want to work, and computers just get mad. It was also hard to have a steady push on the rubber case, and when it moved, the case didn't move in a perfectly straight line along the x-axis, therefore meaning the force was not centered on the object. Also, the initial frame was before I started pushing on the case, and this is wrong. I should have split it into 2 separate sections, one where the net force on the case was just my hand pushing on it, and one where the net force on the case is friction. I should have started taking data from after I pushed the case, when therefore the F net wouldn't have equaled F pushed plus F of friction, where F net should have just equaled the force of the friction. So therefore the physics in the earlier part of this video is wrong. In conclusion, I learned a lot from this lab about pre-planning and not procrastinating until the last minute so that errors found after hours of work have time to be fixed and edited. Although I was wrong initially, I now understand the physics behind this lab, and I'm thankful that we didn't have to model friction earlier. I should have modeled it, so therefore the net force could have just been the force of friction, and then I would have been able to compare the results obtained in Tracker to the computational model that should have been right. The end. Thanks for watching.